Hey, welcome everyone. I'm Benjamin Cabe. This is really great for me to be here. I'm really happy to be part of this great event. Looking forward to talk with you all. So for those who don't know me, I'm Benjamin Cabe. I'm with the Eclipse Foundation. As you may know, Eclipse does a lot of open source software, and we do a lot around IoT, which is basically why I'm here today. I'm actually in Barcelona today, where the weather is not that nice and where lots of people are in the streets, but I managed to make it. So that's I'm really looking forward to today's session. So without further ado, let me share my slides. All right. So I don't want to spend much time on introducing IoT all over again. It's probably like the 20th time you're going through this since the beginning of the DevFest. But today's focus is going to be more around, well, first, the typical IoT architectures, like at least I want to share my take on that, and basically the Eclipse IoT's community take on that, and talk about what's available in open source to implement IoT. So, yeah, IoT is all about connecting things, sure, but it's not, I mean, it's not an end, right? Like, I mean, yes, you can put a sensor on your dog's collar, so what? It's more about what are you going to do with the data? What are you going to do with the information? So to me, it's really about the applications, right? And I mean, some people talk about digitalization. That's what it's all about. How do you turn the physical world into something meaningful, into data, into information, something that you can make value out of, like not necessarily money, but at least value, right? So the way you typically get to a point where you turn your physical world into actual meaningful information is by means sensors, right, that are in the field that you need to bridge to the good old internet and expose. You want to make them available through APIs, basically. And since your constrained devices don't necessarily have connectivity, you need to have some kind of gateway that will provide not only the internet connectivity, but maybe, and even more importantly, will provide some edge computing capabilities to help control and orchestrate the flow of information back and forth between the devices and the cloud. So just to make sure we are talking about the same things, what I mean by a device is really like a constrained device. So that's like when you talk about billions of devices in the IoT, that's what I'm talking about. Those are those devices constrained, usually low power. Like you want to run your device, your sensor for years out of maybe out of a coin cell battery, very specialized. So not only in terms of functionality, and like the functionality that the device provides is very specialized, but it also has obviously impacts on the software that you're going to run on your device. So it's not like you will be able to have a full-blown super flexible software framework, and you're going to have to make choices, right? So that's why some design decisions will have to be done software-wise, and this is why it's important to have access to a wide portfolio of software libraries, if you will. At the gateway level, we are talking more about providing the connectivity, right? And that includes being resilient to connectivity issues, right? Like you want to connect your devices to the internet, but sometimes because of poor cellular coverage, or because you cannot afford to being connected 24/7, your gateway might have some and require some intelligence to basically do some processing of the data at the edge, store the data, and forward the data again when the connection comes back, right? And in general, I mean, it's basically turning what's the what's on the device physical information into more of a set of messages, if you will, and doing messaging using actual messaging protocol to turn and to veiculate the data from the devices. At the cloud level, it's all about scaling, obviously, and like it's probably, I mean, you can think about your IoT cloud as good old IT and good old cloud computing and whatnot. But I guess some specific things start appearing when you do IoT, in that when you design your enterprise backend for dealing with home automation data, well, it's very likely that the rate and the frequency at which the data is being pushed to your backend, it's not necessarily the same as a backend that's been designed for industrial IoT. And yet, if we really want to start thinking about IoT as in an internet, a worldwide internet of things, it's likely that the cloud components will need to be able to deal with the heterogeneity of the different use cases we're going after, and it has implications on also how you integrate all the different cloud bits with one another, and it all boils down to enabling data analytics, right? So I said I wouldn't spend too long on the introduction, but it turns out I already spent 5 minutes on it, but I think that's useful background. So what we see in IoT is that basically to implement this architecture where you have basically devices, gateways, and cloud backends, it basically boils down to 3 software stacks that you need to deploy in the 3 tiers, if you will, of any IoT solution. And so it goes all the way from the constrained, very limited devices to the cloud. There's also some cross-layer concerns, if you will. So things like security, obviously, is important and is something that's needed all across the spectrum. Data semantics, ontologies, and of course tooling, right? You need to develop your solution to have maybe access to simulators and things like that. So that's also important, right? So what do I mean by and I mean, why is it important to think of open source when it comes to building an IoT solution? Well, it's all about making sure that when you build your solution, you're not betting all your business on a particular vendor, right? I mean, IoT has been around for decades, really. Like, it used to be called M2M. There's been many variations of IoT over the years, and there's great solutions available out there. Just like if you think about internet in the early days and the World Wide Web and whatnot, like in the early and mid 90s, AOL, CompuServe, you would have like really great integrated solutions for doing instant messaging and file transfer and whatnot. Except that, well, if you were a CompuServe user, chances were it was difficult for you to actually interact with with people on other networks. So it's the same for IoT, and it's important that when you build your IoT gateway, well, maybe at day one you want the gateway to integrate with AWS IoT, but in terms of protocols that you're using and APIs, etc., ideally you want you don't want to be coupled to a particular backend or to be coupled to AWS IoT backend, right? And same for your devices. You don't want your devices to necessarily be coming from vendor A if you're also getting the gateway from vendor A. You need flexibility, you need freedom, you need to be able to make, like I was saying earlier, like the devices are typically very specialized. Well, it's likely that one particular vendor will have a device that's even more suited to your needs than another, right? And it doesn't. It might have impacts on the software that you decide to put on those. So yeah, it's all about making sure that the stacks are loosely coupled, that they are modular within each stack. Say within the gateway, you need and you want to be able to replace the communication layer from one protocol to the other, right? You may require that flexibility if you decide over time that for bandwidth reasons or whatever else, you want to switch from say MQTT to CoAP or to HTTP2, you name it. You want the independency towards the platform. You want basically like to think more in terms of containers, if you will, and have like a nice abstraction of whatever is underneath your device, like what's the real-time operating system you're going to use, or are you going to run on bare metal? Ideally, this has a limited impact on the actual application that you build on top of the device, etc., etc. So jumping into more concrete examples, and this is where ideally and hopefully we'll get more interactive. I want to share some feedback and some of the stuff that's happening in the Eclipse IoT community. Like you probably know, there's lots of open source foundation out there and lots of open source communities like Apache, Linux, Eclipse. At Eclipse, we've been for the past 6 years, 6+ years, building an open source community, basically around IoT, to provide good, reliable open source software that developers can use to build their solutions. Often those open source projects would be actual implementations of standards, communication standards, security standards, which is actually important thing to have. Like, not only is open source interesting there, but the ability to build on top of open standards means that it brings even more modularity, and it's also all about the collaboration. That's what I want to talk about today in more details. So just to keep you folks hooked to the rest of the presentation. Basically, like I said, we've been around for 6 years, and there's a lot that's available in our community. I will do my best today to walk you through some of the stuff we are working on. There's 30, I think it's actually more than 30 now. We keep getting more project, more technology joining the community. So 30 different open source projects. It's more than 2 million lines of code. There's, I think, over the last 12 months, that's more than 250 developers who've actively participated to enhancing the different projects and adding new features, reporting feedback, etc. And there's really a lot of things going on, and we'll see actually later in the presentation that it's open source goes beyond just the projects, right? I mean, the code is one thing, but it's also about like enabling people to do business, like whether you're a startup or whether you're thinking about building an IoT solution and turn basically your idea into a business. Like, you want more than the technology at some point. You want a whole ecosystem, which is what we have basically at Eclipse. So just so unless I'm mistaken, I'm following the questions that you guys are or will be posting on the chat. I don't see any right now. Just to be clear, I'm actually monitoring the questions. So if there's something that you want me to answer straight ahead, feel free to jump in on the chat. Otherwise, we'll just chat at the end. So this is our community of members. So basically, yeah, for all the way from hardware manufacturers to system integrators, there's lots of companies involved and making Eclipse IoT real. And for those of you who've been sort of following what's been happening in the community for the past 6 years now, there's a lot available, and we like to say that we started with building blocks, like with open source components that basically people could use sorry, I got distracted. Yeah, so open source, I mean, there's different ways to consume open source. usually, and at least when we started, we had a collection of libraries for, say, a library like Eclipse Paho would help you do MQTT communication, or a library like Eclipse Mosquito would actually be the server-side implementation of the MQTT protocol. But when you think about building an IoT solution, well, I mean, you can start virtually from scratch and start assembling all those building blocks together, and maybe you'll get some components and some libraries from Eclipse, and maybe some others from Apache, and then maybe some system integrator out there, or some vendor will have other libraries that you can use and that will help you. But at the end of the day, you're spending a lot of time integrating the different building blocks into a stack, right? So 6 years ago, we started with the building blocks. Now we're getting more towards an integrated stack, right? And the stack for the constraint devices, a stack for the gateways, and the stack for the cloud. So starting with the devices. So from now on, for the next 15 or 20 minutes, I will be talking about the projects, like the actual technology that's available at Eclipse. This won't go into lots of technical details because there's just so many projects to cover. But like I said, I do want to answer your questions. Should there be any? So if you are already familiar with some of the projects and have more in-depth questions, or if there's one project that I mentioned and for which you would like more details, that's what I'm here for today, basically. And just because this conference is really cool, and I'm again really happy to be here. So constraint devices, I didn't go into the details of what's typically in the device stack when I presented the 3 stacks earlier, but from a high level point of view, it's three things, I guess. One is so eventually on your device you want to deploy your own custom app, right? Your own custom logic for doing control of your smart thermostat, or for monitoring heart rate on a wearable device. So one thing is you want your application to be somewhat hardware independent. So ideally, on top of your constrained device, on your microcontroller, basically, you want some kind of hardware abstraction layer, right? All the APIs, all the abstractions for manipulating the IOs, manipulating the serial interfaces, etc. You want some kind of abstraction for that. You want also the ability to communicate with the rest of the world. Likely, you're going to communicate with the gateway, right? So the at least in my take on the constrained device, at least as of today, you probably don't have IP connectivity yet. You have something maybe like Bluetooth, Zigbee, Z-Wave. So how do you communicate with the rest of the world is important, and you need software libraries for that. And last but not least, and we'll see this bit and this part in basically all the 3 other stacks. This is the remote management, right? So remote management for basically being able to, once your device is in the field, you want to be able to deploy new firmware upgrades. You want to be able to maybe reboot, rekey your device over the air. So that's the remote management side of things. So in terms of hardware abstraction layers, at Eclipse, there's an interesting project called Eclipse Edge, which is basically, and I know this sounds weird and or scary and or funny, but with Eclipse Edge, basically you have a Java-like API on top of your MCU, right? And you have the ability to write Java code that will eventually run on either the OpenJDK JVM or other more embedded kind of JVMs. And the idea is that there's a nice and way nicer than in default JDK. There's a nice API, a nice abstraction of all the hardware capabilities. So if you're interested in that, check out Eclipse Edge. Communication-wise, there's many ways for your device to communicate. We don't, at Eclipse, we don't necessarily focus on like the implementations of the radio protocols. But just on top of the radio protocols, you can do things like MQTT, right? And things like maybe MQTT-SN, MQTT for sensors, sensor networks. So if you want to get a nice and easy to embed implementation of MQTT, you can get that from Eclipse Paro. That's one thing that you might want to check out as well. And I wouldn't say the most interesting part, but at least maybe the most unique is for remote management. We have a very popular project called Eclipse Wakayama, which is an implementation of a standard called Lightweight M2M, which is basically a standard for doing device management. So all things firmware upgrade and remote monitoring of the amount of memory that your device has left and stuff like that would be part of the Lightweight M2M standard. And with Wakayama, you have a C implementation of that standard that people would typically take and bake right into the firmware of the device, right? So there's actually lots of companies out there, Sierra Wireless, Samsung. I would like to say Intel, but I'm not 100% sure. So those companies basically take Wakayama and they bake Wakayama right into the firmware, which means that no matter what, you know that you'll always be able to interface with the device and to communicate with the device to do very low-level device management and maintenance kind of stuff, right? And of course, and I mean, if you're interested, there's lots of literature around it. This is secured, right? So this builds on top of DTLS. So this is like Lightweight M2M is based on UDP, and so thanks to DTLS and to either like regular PKI solutions or like pre-shared keys, you can make sure that only trusted parties can effectively do low-level device management stuff with your device. So that's for the constrained device stuff. I still don't see any questions, but please make sure to be very vocal if I need to slow down. There is actually a question from Oleg just now. The question is there an example of a constrained device which would be, for example, based on an ST micro and an STM32 microcontroller that would run Edge? And actually, that's a very interesting and to-the-point question. So Eclipse Edge is developed and maintained mostly by a company by the name of MicroEJ. And so if you look at, well, not only at Edge, but at what MicroEJ is doing, I do believe that the STM32 is actually sort of their reference award, right? So for those not necessarily familiar with the STM32 sort of portfolio in general, we're basically talking about devices with RAM in the range of dozens of kilobytes and flash around maybe 100K or 200K. So you like almost Arduino Uno, and plus, if you will, a kind of microcontroller. But on those kind of devices, you can actually run not only Edge, the Java API, but also the actual VM, right? So MicroEJ is providing a VM, but there's also I mean, for on devices slightly more powerful, you may want to go with an Azure JVM, or there's actually the Eclipse OpenJ9 Java Virtual Machine, which is another option, or of course OpenJDK. So yeah, check it out. Any follow-up questions, Oleg or others, feel free to reach out on the Edge mailing list or to me directly. You have my Twitter handle at the bottom of my slides as well for any follow-up questions. I think I will put my email address at the end as well. Thanks for the great question, Oleg. And it's also reassuring to know that I'm actually talking to people, because it's hard to know whether the sharing and stuff actually works, and now I know it does. Switching and moving on to IoT gateways. So what do I mean by a gateway. Like I said earlier, this is all about providing the connectivity to the constrained devices. And like if we take the example of an STM32 microcontroller, maybe you will have some ways to connect it to the internet, right? Maybe it's already capable of doing 6LoWPAN, or maybe you have some shield, some extensions for using an external modem, and somehow your microcontroller code will directly be able to talk to the cloud. But chances are you're better off with a gateway. Like, there's lots of things that you need to do in order to manage the connectivity itself, right? Like, I mean, on your microcontroller, what do you do when the connectivity and the link drops off? Like, do you store all your telemetry information locally in RAM or in Flash, and you wait that for the connection to come back? And maybe it'll take 24 hours, and you will have lots of data points that you might not even be able to store locally, right? So there's that. There's the computing power that you may require if you like if you're collecting lots of information. Maybe you want to actually do some heavy lifting and pre-process the data. I'm not sure you can or want to do all that on your micro, right? Even if the micro has the connectivity in the first place. So my take on the gateway, that is basically a device on steroid. So you may want to call it a smarter or smarter device. And basically, it's about providing advanced connectivity management. So not only you want the gateway, and very likely the gateway will come with out-of-the-box support for many protocols. And very likely, like what we call field protocols, you would find gateways in usually in industrial environments, right? So protocols like Modbus or PCUA, maybe CAN bus if the gateway is more in a car environment. So support for those protocols is important. Support for the network management per se. So firewall, managing all the different bearers that you may want to use for connecting your devices. Maybe the gateway will use Ethernet or Wi-Fi as the primary bearer and the primary way to connect to the internet. But maybe the gateway is configured to fall back to cellular if the wireline dies, right, for some reason. And like I said earlier, the gateway is all about turning your sort of raw telemetry information into more meaningful messages. And so you will very likely find gateways that support messaging protocols like CoAP or MQTT or things like that. So at Eclipse, there's at least three actually, I believe, gateway solutions. And depending on what you're after, you will look at one or the other. If you're more into building and a sort of general purpose gateway, and you want to have access to a stack that will provide you with all the functionality that I just described and allow you to build your own custom application on top of, you likely want to look at Eclipse Cura, which is basically, for those of you familiar with OpenWRT, this is sort of similar in terms of functionality. Like, you have a stack to turn your device, Raspberry Pi, BeagleBone, whatever industrial PC, into a router, right? So you will have all the UI, all the APIs to administrate and to configure the gateway. But what's more, you also have an application container. So Cura would come with built-in support for communicating over serial, to do Modbus, to do CAN bus, and things like that. Will come with support for managing all the connectivity. Will come with the abstraction of the messaging side of things. So as an application developer, I want to get data out of a Modbus PLC, and I want to push this data to the cloud. So Cura provides me with all the APIs to make that a seamless experience, sort of. And as opposed to having to figure out what do I do if the network is down, what do I do if there's an error getting my data from the Modbus device, etc. There's lots of abstractions in Cura to not have to deal with this complexity and to not have to reinvent the wheel every time you have to build an application. So Cura is based on Java, by the way, on Java and OSGI, and yeah, you can easily take Cura, install it on. There's lots of examples out there on how you run it on Raspberry Pi, etc., etc. So you should check it out if you're more into. So that's the overview and the high-level architecture for Cura. There's lots of tutorials out there. You may want to check it out. If you're more into home automation and home automation gateways, basically, Eclipse Smart Home is a really, really popular project, which you might actually already be using, and you might not be aware of the fact that it's Eclipse Smart Home under the hood. Eclipse Smart Home is the foundation and the framework underneath OpenHub, the Open Home Automation Bus, which is a really, really popular home automation framework, which has like hundreds of home automation protocols supported. And the foundation for OpenHub is actually hosted at Eclipse. And there's lots of companies like Orange, like Deutsche Telekom, like Huawei, who basically take the framework and build their own home automation solutions on top of it, right? So they have set-top boxes or all kinds of home automation boxes that build on the home automation, on the smart home automation framework, and things like the rules engine, like the fancy UI, the mobile UI, are all available in open source, and you can you can either take the technology as is and build on top of it, or use it as an end consumer, or you can take the technology, tweak it, and build your own products on top of it, right? So now moving on to the cloud, there, I guess, I have 2 points. One is we have lots of we've been moving into the IoT cloud space for quite a while now, and there's several projects that are available that can help you address some of the concerns that are required for building an IoT backend, if you will. So, and those are actually very unique projects. If you need, at some point, you will need to manage the software for your devices, right? So if you have just 1, 2, 3, 10 sensors out there, well, maybe you're better off with sort of a manual scripts, and maybe you will log manually and SSH manually into your devices and do the updates that way. And if something goes bad, you go in the field and you reboot the device and whatnot. If you have a more complex fleet that you need to manage, things like Hogbit or Leshen are very likely going to help you. And it's no surprise that companies like Bosch, Samsung, Sierra Wireless, Yourtech, Red Hat, and many others use those technologies. Hogbit, for example, is think about what happens if you have 1,000 or hundreds of thousands of devices in the field. You want to deploy new firmware, but like maybe your firmware is like 100 megabytes, right? So you don't want to push 100 megabytes of firmware to thousands of devices at the exact same time. You're just going to kill your network. You're going to kill your data centers if you do that. So with Hogbit, you can model, you can describe an actual upgrade campaign and model a rollout that's going to happen maybe over the course of a week or two, right? And you can also model what happens if I start deploying my firmware upgrades and 90% of the devices just die afterwards. They just stop reporting any kind of data back to the server. So maybe something's wrong, and Hogbit will decide and will realize that it's better to just stop doing the upgrade campaign altogether, right? So with Hogbit, you have all this infrastructure, including a complete UI, a complete set of APIs for you to integrate with your existing backend systems. And there's a great community around Hogbit. There's lots of examples out there on how you can use Hogbit to manage Android or Android Things devices. So really something to check out. Leshan is, to put it simply, is the server-side counterpart of Eclipse Wacom that I mentioned earlier. So the server-side implementation of lightweight M2M, which is, well, pretty useful when you want to manage lightweight M2M constrained devices. But so those are two building blocks, if you will. Mosquito is another. You're probably familiar with Mosquito if you're doing MQTT. So that's basically the broker that you can use to connect and interface all your MQTT devices with one another. But where I'm getting here is that, I mean, Hogbit, Leshan, Mosquito, those are great pieces and great building blocks, but you need integration at some point, right? Like when you start having devices that communicate over MQTT, and when you start managing devices through Leshan or Hogbit, chances are you want a common platform that manages the identity of those devices, that manages who has access to the devices, what are the security rules and the access control rules, etc. So that's what Eclipse Kapua is about. So basically, Kapua is a container for all the microservices that might be needed in an IoT solution. And what's happening with Kapua is that you basically run Kapua on top of Kubernetes, on top of OpenShift, on top of Cloud Foundry, and you have an integration platform for all your microservices. So things like Leshan, Hogbit, Hono, which is more about the pure connectivity side of things. Those are all microservices that you can deploy in Kapua, and Kapua provides a common set of APIs to interface with the services, a common UI, and you can of course develop your own microservices to add even more functionality into the backend system. So that's for the technology. Very briefly moving through some of the cross-layer concerns that I mentioned earlier. So I will be going really quick here. For security, there's actually a pretty interesting project called Eclipse Kitty, which actually comes out of the Predix platform. I think there's been a couple presentations and sessions about Predix at the DevFest since yesterday. So basically, Kitty is a way to do authentication. It's OAuth on steroids, if you will. So like fine-grained and modular management of access control for who has access to what resources, who can read the telemetry stream from what devices, who can send commands, etc., etc. So that's a pretty nice and pretty modular framework coming out of GE and Predix. Data modeling and semantics and ontologies. Check out Eclipse Righto. So lots of Righto provides data models for many sensors, as well as generators and tools that people can use to easily bootstrap applications. Knowing what devices you will manipulate, you can start generating and bootstrapping some of your UI code or some of your Cura code, maybe some maybe your Arduino app as well. That's a pretty interesting one. Tooling-wise, there's lots of tools available out there. Of course, like Eclipse has the Eclipse IDE, so you can use Eclipse CDT for your C development. Eclipse J if you want to develop in the browser. Check out MQTT Spy for all things MQTT, and if you want to have a nice tool for recording, it's basically Wireshark for MQTT. So that's I know that I'm doing lots of name dropping here. That's kind of intentional. I want you guys to do some homework, but maybe afterwards, or to follow up if you have any questions. And so those are like, this is for the technology, right? And there's really a lot. There's like 30 projects, like I said. that fit into the 3 different stacks. So you have the link to the slides, and I like I said, I hope that you guys will be doing more research afterwards and look for the tutorials, look for the videos that we have. There's even more projects that are coming up. Eclipse Cyclone will be implementing DDS, which is an industry standard for communication in distributed systems, and like large-scale systems. And when you want to do real-time messaging, like you want really critical, implement really critical quality of service mechanisms and stuff like that. Eclipse Ditto is going to be pretty interesting. Like we hear a lot about digital twin these days, and basically you can have a complete open source implementation of digital twin with Ditto. We have something coming out of W3C Web of Things work, which is going to be called Eclipse ThinkWeb. So that's also something to look out for. And this is basically, I mean, I want to wrap things up, and Leila is asking about some links to get started. This will come in just a few slides. I want to wrap things up with things that's not necessarily technology specific and not necessarily related to the code. Like when we started, it really was building blocks, like I said, and almost you could say like hackers and makers in their garage. But now we're really seeing lots of industry adoption, right, of open source in general, and even more so of open source technology coming out of the Eclipse IoT ecosystem. This is a picture and the presentation from Bosch during their big annual conference. And basically, in this presentation, what Bosch was saying, and we have many other companies who basically share the same story, they are shipping and they have an IoT platform of their own, right, with like commercial services and like lots of business and like commercial stuff coming out of Bosch, but it's all built on top of Eclipse IoT technology, right? So for all the different components of the Bosch IoT suite, you would find the equivalent in open source, which means that basically you as a developer can start building, prototyping your solution with pure open source software and including open hardware platforms, etc. And when you want to transition to something more like customer oriented and with like real professional services around it, you have companies out there who build real commercial products out of the open source technology, which is, I think, very important, right? We do lots of things beyond just the open source projects. We have a virtual IoT meetup. This is actually similar to the DevFest, I guess, except that it's well, it's only once every 2 weeks usually. So this is an online meetup where basically we spend an hour every other week with industry experts to talk about open source technology for IoT. And there's lots of good resources there. If you want to look at the recordings of the previous meetups, I have a link coming up in just a few slides for that. We organize IoT challenges, and I have more about that in just a minute. The IoT marketplace, this is something pretty new, but now basically what this means is that for projects like Eclipse Cura or Eclipse Smart Home, if you want to discover and to find new plugins, new functionality to extend and to enhance your gateway frameworks, you can get them from the Eclipse marketplace. And if you are an application developer, you can actually make them available there as well. So this is basically an app store for all things IoT, right? So I think this is something that's pretty unique as well. And you can again, like you can either consume data software and plugins out of the marketplace, or if you're a vendor or an integrator and you have cool technology that you want to disseminate, you can put it out there. You can even like maybe have like commercial plugins and sell licenses and whatnot if that's what you're after. One other thing is we do test beds, and to the point of to Leila's point about sharing some links and resources to get started. The testbeds are certainly one. So we have lots of tutorials available, but with the testbeds, we go one step further in that we work with vendors and with actual companies on real industry solutions and like end-to-end IoT solutions, such as waste management using IoT, asset tracking management. How do you manage shipments from like that go through trucks and planes and whatnot? How do you do smart manufacturing? And we implement this with open source, and we showcase and we make available the code that's behind an actual solution, right? So, for example, asset tracking management. How do you track and monitor where a parcel is, like your FedEx or UPS? Where's my parcel? And I want to be able to tell my customers where the parcel is and what's the current temperature and whatnot, so that you reduce like maybe the amount of lost parcels and to improve the quality of service to my customers, etc. Well, we implemented just that through open source and using IoT gateways from Samsung and from YourTech, using sensors, TI sensor tags as the sensors, Cura as the gateway framework, running the IoT backend on OpenShift and leveraging Eclipse Kapua. So there's like a real end-to-end application all the way from the sensors to the actual dashboard that you see, sorry, on the right-hand side here, with like maybe a map of where the devices are, etc. This is all available on GitHub, right? You follow this link, you have a link to a demo, you have a link to all the code. You can replicate the demo yourself. You can, if there's something that's missing, maybe you want to add your own secret sauce and your own elements to that. So that's, I think that's pretty unique and pretty interesting. There's other testbeds around Industry 4.0. If you guys have ideas or would like to get involved in more in similar initiatives, reach out to me. I mean, that I think I'll be really interested to talk to you in that regard. I mentioned just before the Open IoT Challenge, so that's one of the takeaways I think I have for you today. I would assume that many of you are IoT enthusiasts and IoT developers. We want to encourage, and actually we are partnering and with Intel on this particular initiative, and we are really happy to have Intel as a sponsor. We do our fourth edition of our Open IoT Challenge, which is, in a nutshell, build something cool using open source and whatever else you think is useful. Like, it's also fine if you require some commercial stuff to build your solution, but build something cool. You have until the end of mid-March next year to do that. The only thing that we ask you to do is to enter and to submit a proposal by November the 13th. So just describe briefly your project. I do realize I forgot to put the link, so that's really too bad, but it's really easy to find, iot.eclipse.org/OpenIoT-challenge. Please submit a proposal. If your proposal is well articulated and already pretty promising, you will actually get a voucher to buy some hardware. Like, I think it's $150 that we will give away to the 10 best proposals. So even if you don't win the grand prize come end of March, you can already get some cool gifts. So any questions or any feedback you need, you're not sure whether your idea is good enough, etc., feel free to reach out. I'd be happy to fine tune the proposal with you guys. Leila, those are your links and your resources. Lots of resources on the Eclipse IoT website. I do blog quite a lot about some tutorials and some sort of getting started guides, so you can also follow that and subscribe to my blog. Should you want to engage with the projects, usually, well, I mean, and all the time, actually. All the projects would have either a forum or a mailing list or both. And all the projects are usually very helpful to answer your questions, including super beginners questions. Lots of videos on YouTube. Like when I say lots, it's really a lot. We organize lots of conferences, and we have lots of speakers from all around the world who talk at our conferences or our meetups, virtual IoT meetups. So check out the list. Subscribe to the meetup. We have sessions, like I said, every other week, and we'd be happy to also have you at the meetup, speak at the show if you have something cool you want to share with the community. I think that's what I had for you. So I promised that we would have around 20 minutes for chat and questions, which doesn't look like we do. It's more around 9 minutes, but still. So this is our website, and this is my contact information. Like I said, you already have my Twitter handle, and you also have my email address here. So Dave is asking, what are the major reasons or driving factors in terms of like technically or in terms of cost, effort, etc., for choosing to implement open source IoT solutions versus the various vendors IoT turnkey solutions that are there? Probably, I mean, things like AWS IoT, Azure, etc. Well, if we think about, I mean, there's lots of platforms out there, and there's lots of platforms that do the job, right? I mean, like AWS IoT, again, Azure IoT, IBM Bluemix, etc., etc. I think it's all, it's at least two things. One is the vendor lock-in, not saying that Microsoft or Amazon and others deliberately want you to be locked into their platforms, but chances are you like when you start putting your hand into those platforms, well, you're basically bound to using their services forever, because you will start building lots of maybe internal competencies for a specific framework, etc., and you end up losing flexibility, right? What happens when the pricing model changes for the hosted platform? You might have a problem, right? It's also about like what happens when some devices or some use cases are not supported by the vendor solution. I mean, maybe you throw more money at them, and they might work with you to add the functionality. Or if you're based on at least on some open source components, you have more and more freedom to do to implement the stuff yourself. And I think another aspect of using open source is well, one is innovation. Arguably, with open source, developers can more easily start doing stuff without having to ask for permission. Like, you don't have to talk to sales representatives or to technical contacts within the vendor the vendor's company to be like, okay, how do I do this and that? You just figure it out yourself, and you start innovating that way. And I think open source is also, and we see it clearly with MQTT, for example, it's about talent recruitment, if you will. Like, MQTT has been open source for close to a decade now, and if you look at, for what it's worth, I mean, it's for better or worse, you can look at Google Trends for MQTT, and you will see that lots of people, lots of developers are now very knowledgeable and use basically MQTT as the de facto standard. I don't believe this is because some vendors decided to put MQTT in their solutions. I think it actually, and if you look at the history, it actually started with MQTT being open source, and therefore lots of developers starting to build solutions on top of MQTT, building proof of concepts, etc., and basically asking and pushing the vendors to integrate the protocol into their solutions, right? So I think that's my way to answer your question, Dave. Santosh, can these open source IoT ecosystems be used to build a home automation commercial products? Could you please provide examples? So like I said briefly in my presentation, if you look at something like Eclipse Smart Home, that's the perfect example of a stack, an open source stack for doing home automation. Lots of hobbyists doing home automation with Eclipse Smart Home, but lots of companies as well. And actually, if you go, and I could basically share my screen and go there and show to you all, if you go to the Eclipse Smart Home website, you will see that there's many ways for companies to do commercial products out of Eclipse Smart Home. Namely, and maybe most importantly, one is Deutsche Telekom. They have a white label box that they sell and manufacture for providing home automation capabilities in set-top boxes and for basically residential gateways. So they do make money out of Eclipse Smart Home. So several ways. One is, well, they sell services, they sell support, training, they sell maybe some commercial add-ons, commercial plugins that might not be available in the open source ecosystem. Sometimes the reason is actually in terms of licensing, it might not always be possible to make some plugins available in open source. You require some license, etc. That's where a vendor ecosystem can help you, right? There's other companies in the Eclipse Smart Home ecosystem who purely sell training, right? I mean, you can look it up. You can have companies that for which the added value is really just around data science, right? So they would integrate with something like Eclipse Smart Home, and they would sell you their expertise and their services to extract some meaningful data and some meaningful value out of all the sensor data, all the information that you collect through the framework, right? So yeah, check out. I can actually I will post the link on the chat. So that's on the eclipse.org/smarthome webpage, and more specifically, yeah, there's a section on the references, right? If you scroll down on the page, you'll see that I didn't name it. I mentioned that it's called Kivicon, the framework from Deutsche Telekom, but there's there's at least six companies that are listed on the homepage, and I'm pretty sure the homepage hasn't been updated with the latest developments with the likes of Orange, Huawei and others who also deal commercial products. So that was my answer to you, Santosh. So just a quick maybe show of hands. Among all the different projects that I mentioned, were you guys already familiar with some of them? I guess maybe one way or the other, maybe you've been using Paho or Mosquito in the past to do MQTT. Is this assumption correct? And or are there other projects you were already familiar with? You know where to find me. You have my slides. I know there's a lot in there. I mean, maybe not too much and too many technical details, but I hope you trust me in that we have cool stuff, and you should check it out. Thank you all very much, and we'll be in touch.